Narrator: slow, cinematic, gripping. They said it was impossible. They said the machines were too complex, the assembly too delicate, the stakes too high. Experts swore that automobiles and heavy bombers belonged to two different worlds, worlds that could never collide. Visual: close-up of rusted aircraft parts, transition to roaring assembly lines, workers frozen mid-motion. But then Henry Ford did what Henry Ford always did: he broke the rules. A whisper of machinery fills the air. The hum grows louder. Metal clanks, sparks fly, and shadows move across an enormous industrial cathedral. Visual: sweeping drone shot of Ford's Willow Run plant in 1943, the largest factory on Earth. Narrator: in 1941, the United States needed bombers fast. Not dozens. Not hundreds. Thousands. Tens of thousands. Enough to overwhelm enemy skies across two oceans. And there was one aircraft that could change everything. The consolidated B-24 Liberator, the most complex, advanced, and difficult bomber America had ever attempted to mass produce. But a problem emerged. Traditional aircraft builders said mass production was impossible. Every B-24 required 1.2 million parts, kilometers of wiring, 8,000 feet of tubing, and intricate labor by highly skilled craftsmen. These weren't cars, these were flying fortresses. The experts insisted, "You can't build a bomber the way you build a car." They repeated it. They wrote it in reports. They testified before committees. And yet, within just 2 years, Ford's Willow Run plant was rolling out one B-24 every 55 minutes. An airplane every hour. A bomber before lunch, and another before dinner. Visual: time-lapse animation of bombers rolling off the assembly line like cars. How did a car company accomplish what aviation experts called madness? How did Ford revolutionize wartime manufacturing using methods no aircraft designer believed could work? The war begins and America panics. December 1941. Pearl Harbor burns. Japanese forces sweep across the Pacific. Nazi Germany dominates Europe. America faces a terrifying truth. It is far behind in war production. The U.S. Army Air Forces project that to win the war, they need 50,000 combat aircraft. Ford, Chevrolet, Chrysler, every factory capable of building anything was pulled into the fight. But one requirement stood above all. The Allies needed a long-range bomber that could fly farther, carry more bombs, and endure harsher missions than any aircraft in history. The B-24 Liberator. Its nickname? The Flying Boxcar. Not elegant like the B-17. Not beloved. But deadly. Efficient. A war winner if enough could be built. The problem was production. Consolidated aircraft could not meet demand alone. They struggled to build even one bomber per day. A day. Not an hour. A day. And the war was moving faster than American factories. Enter Henry Ford, the man who built America's wheels. Henry Ford was 78 years old when America asked him for help. Bad heart. Shaky hands. But still dangerous. Still brilliant. Still stubborn. Ford believed in mass production, in conveyor belts, in industrial choreography so precise it resembled a ballet of steel and sweat. He told Washington officials, "Give me a big enough factory, and I'll build you anything. Anything. Even a bomber. Handcrafted aircraft? No." Ford would build them the Ford way, with high-speed assembly, interchangeable parts, and thousands of workers doing small tasks quickly and efficiently. Experts laughed. They mocked him. They insisted aircraft production required elite mechanics and aircraft craftsmen with years of training. Ford told them one sentence that became legend. "If we can build a car a minute, we can build a bomber a day." He was wrong. He didn't build a bomber a day. He built one an hour. But not yet. Before the miracle came the disaster. The factory that defied reality. The location. A swampy farmland area west of Detroit, Michigan. Ford's engineers surveyed it. They shook their heads. The soil was wrong. The location was isolated. The nearest rail line needed reconstruction. The water table was too high. Ford didn't care. He pointed at the empty farmland and declared, "Build the largest factory in the world here." Visual. Blueprint animation of the Willow Run plant slowly appearing on screen. The result was a building so massive it stunned architects. 2.5 million square feet of factory floor. A mile-long assembly line. A structure so enormous that workers used bicycles to move around inside. It became known as the arsenal of democracy. But inside this colossal structure, problems were growing. The impossible challenge. What Ford didn't know was that the B-24 was not a car and never would be. Workers struggled with the bomber's complex hydraulics. Parts didn't fit. Sections warped during assembly. Engines misaligned. Rivets cracked. Ford's mass production philosophy collided with aviation reality. Wings were too difficult to build on a moving line. Fuselage sections required expert hand-fitting. Skilled aviation labor was scarce. Machinery broke under the bomber's scale. Workers joked, "We're building 2 airplanes, a good one and a spare one made of mistakes." Government officials panicked. Some wanted to shut Willow Run down, and yet, the turning point. When the Army Air Forces visited the plant, they were stunned, not by success, but by potential. Despite all the failures, the chaos, the delays, Ford had built something no one else had. A factory designed to build airplanes the way America built cars. If he could make it work, Allied air power would become unstoppable. And so Washington gave Ford one last chance. One final ultimatum. Fix the problems, or shut it down. Under the fluorescent glow of Willow Run's unfinished assembly lines, thousands of workers braced themselves. This was no longer about manufacturing. This was about survival. American survival. European survival. A war that could be won or lost based on a single factory's output. Visual. Slow-motion shots of workers tightening bolts, riveting metal, sparks flying, sweat dripping. The stakes had never been higher. The question that changed history. Experts still shook their heads. Planes and cars were different. Too different. Too complex. Too demanding. But the Ford philosophy asked a different question. What if complexity can be broken into 100,000 simple steps? And the world would soon discover the answer. Because Willow Run was about to do the impossible. To turn aircraft craftsmanship into industrial mass production. To turn chaos into precision. To turn failure into victory. And most unbelievably, to build a B-24 every hour. Narrator, final dramatic line. This is the story of a factory that defeated experts, defied logic, and armed a world on the brink. This is the miracle of Willow Run. Before Willow Run became the beating heart of America's wartime industrial miracle, the story began decades earlier, in a world that had no idea it was racing toward the most destructive conflict in human history. The 1920s and 1930s were eras dominated by radically different visions of industry. Aviation was handcrafted, slow, artisanal, while automobile manufacturing was fast, brutal, and efficient. Aircraft factories resembled workshops, filled with engineers wearing magnifying lenses, carefully shaping aluminum skins by hand, adjusting rivets one by one, building machines that were closer to sculptures than weapons. In contrast, Ford's factories were mechanical cities, roaring with fire, steel, and endless movement, pumping out millions of cars using the assembly line system Henry Ford had mastered. To aviation experts, the idea of mixing both worlds was absurd. Airplanes, they argued, required a kind of precision impossible for mass production. And for a long time, America accepted that belief. B-roll, airplane craftsmen hand-fitting wings, slow pan of 1930s aircraft factories. But by the late 1930s, the winds of war began to sweep across the globe. Nazi Germany surged across Europe with a modernized war machine. Japan expanded aggressively across Asia. Factories in Europe were already running at maximum output, while American production was still trapped in the comfort of peacetime pace. The United States was a sleeping giant, rich in resources, brilliant in engineering, but painfully slow at recognizing what was coming. By 1940, Britain was nearly out of aircraft. German bombers hammered London, factories burned, pilots fell faster than replacement planes could be produced. Britain begged the United States, "Send planes. Send anything that can fly." America responded, but slowly. Too slowly. Traditional aircraft plants could produce only a few dozen heavy bombers a month. But the U.S. military needed thousands. The B-24 Liberator, with its long range and mass. Just building the wings required tools and techniques entirely different from anything the automobile industry had ever seen. The factories at Douglas, Consolidated, and North American struggled to keep up. The Army Air Forces projected that at the current rate, they would never have enough bombers to fight on two fronts. And so began the desperate hunt for a solution that did not yet exist. B-roll, maps of Europe in flames, U.S. officials studying production charts. Enter Henry Ford, stubborn, visionary, controversial, and unafraid of the impossible. Even in his 70s, he was driven by the same belief that shaped his entire career. Anything can be built faster, cheaper, and more efficiently if the process is broken down into its smallest components. His son, Edsel Ford, already deeply involved in aircraft production via Ford's smaller contribution programs, saw the crisis clearly. America needed someone who could do what all aircraft manufacturers said could not be done. So Ford made a proposal that shook the industry, mass-produced the B-24 bomber using automobile-style manufacturing, complete with conveyor belts, stamping machines, precision jigs, and synchronized labor. Traditional aviation experts scoffed. They said aircraft manufacturing depended on the feel of a master craftsman. A bomber cannot be built like a car, they argued. They are completely different. Even Consolidated Aircraft, the company that designed the B-24, warned Ford that the plane was too complex to disassemble into small tasks. They believed Ford would fail so completely that it might jeopardize the entire war effort. But the Roosevelt administration, desperate for bombers, took a gamble that would change history. They allowed Ford to attempt the impossible. Willow Run was approved. Land was purchased. Plans were drawn. And the Ford engineers went to work. B-roll, engineers drafting massive blueprints, editing production diagrams. The challenge was terrifying. The B-24 wasn't just complicated, it was unforgiving. If even a single rivet was misaligned, if even one hydraulic line was improperly fitted, the aircraft could fail mid-flight, killing the crew. Ford had to find a way to divide the construction of a bomber, normally requiring expert teams, into thousands of tiny, perfect steps executed by workers who had never even seen an airplane before. But that wasn't the only obstacle. The workforce itself would be unlike anything Ford had ever dealt with. Tens of thousands of men were already overseas fighting. That meant women, housewives, secretaries, farm workers would need to be trained to operate heavy machinery, assemble combat systems, and perform work once reserved for skilled male technicians. America had never seen anything like it. For many of these women, Willow Run would be their first job. For some, it would be their first time leaving their hometowns. They would become the beating industrial heart of the war, the legendary Rosie the Riveters. B-roll, women training on drills, stamping aluminum panels. Meanwhile, designers at Consolidated sent their teams to help, only to discover that Ford was re-engineering not just the production system, but the aircraft itself. Ford's approach required redesigned parts, standardized components, and special jigs that forced perfect alignment every time. Other manufacturers saw chaos. Ford saw opportunity. Every single system in the B-24 was broken into subassemblies. The fuselage became a dozen sections. The wings were split into modules. Even the landing gear was redesigned to snap into place at a precise stage on the moving assembly line. Ford wasn't just mass-producing a bomber, he was redefining aircraft manufacturing itself. But everything depended on Willow Run, the massive mega-factory still rising from the mud fields of Michigan. By the time construction began, the scale of the project stunned everyone who saw it. A mile-long building. A workforce expected to exceed 40,000 people. Assembly lines longer than anything ever attempted. Power consumption greater than some cities. And looming above it all, the war. Every deadline missed meant lives lost. Every hour wasted meant Allied defeat creeping closer. Ford promised speed. America demanded results. And deep inside Willow Run, Under the floodlights of a half-finished factory, the machines that would build the machines of war began to awaken. The countdown to the first bomber had begun, and the world still believed Ford would fail. They did not yet understand what was coming. Because Willow Run wasn't just going to make bombers. It was going to make history. Willow Run was supposed to be a miracle, but in 1942 it looked like a catastrophe unfolding in slow motion. The factory was enormous, loud, chaotic, and nowhere near ready for the impossible task ahead. Mud swallowed construction trucks. Machinery arrived late. Workers quit within days, overwhelmed by the brutal commute and grueling hours. Supervisors argued. Engineers panicked. The first B-24 Ford attempted to assemble took months, not hours, and looked more like a battle-scarred prototype than a war-ready bomber. Critics in Washington whispered that Ford's promise had been a fantasy. Aviation experts smirked privately. We told them cars and bombers are different. B-roll. Slow pan across chaotic early assembly line. Workers struggling to fit panels. Then came the tension that nearly killed everything, the sheer complexity of the B-24. Even split into subassemblies, it required thousands of rivets, miles of wiring, hydraulic systems, oxygen networks, machine gun turrets, and landing gear strong enough to hold 60,000 pounds of steel and bombs. Every step had to be perfect. But Ford was discovering problems no aircraft company had faced. Thousands of inexperienced workers trying to build the most difficult bomber in the world. Women who had never touched a wrench were suddenly responsible for fastening critical load-bearing rivets. Men from farms who had never seen a blueprint before now had to read engineering diagrams under pressure. Mistakes happened everywhere. Misaligned parts. Cracked panels. Faulty electrical circuits. Planes that rolled off early test lines sagged under their own weight. Ford executives fought openly. Consolidated engineers threatened to pull out. Meanwhile, the war was getting worse. American forces were now engaged across the Pacific, North Africa, and soon Europe. The U.S. Army Air Forces sent an ultimatum: Willow Run must work. America needs bombers now. The pressure inside the factory grew unbearable. B-roll. Workers sweating under hot lamps, supervisors shouting orders. To make matters even worse, the weather turned Willow Run into a freezing metal cavern during winter. Temperatures dropped so low that breath turned to frost over aircraft frames. Machinery seized. Workers shivered with numb fingers trying to fit tiny components into unforgiving steel molds. Absentee rates skyrocketed. Trains carrying supplies were delayed for days. At one point, Ford's entire assembly line came to a standstill because a shipment of critical rivets was stranded in Chicago during a blizzard. Reporters predicted doom. Senators questioned the project. Even Roosevelt's advisors feared the Ford bomber experiment might collapse. But in the middle of this chaos, something incredible began to happen, quietly, slowly, almost invisibly at first. The workers got better. The engineers redesigned tools daily. Supervisors refined workflows. The massive problems that had once consumed the factory were broken down and solved piece by piece. Ford's obsession with standardization started paying off. Tools were redesigned so that even a new worker could only place a part the correct way. Jigs locked components into perfect alignment. Conveyor timing was recalibrated hour by hour. The once awkward workforce of inexperienced men and women began transforming into a synchronized, unstoppable machine. Experienced workers started training newcomers. Women mastered precision drilling and riveting faster than anyone expected. Entire teams built unspoken rhythms, passing parts down the line with the coordination of seasoned craftsmen. B-roll. Women riveting side panels, men welding frames with sparks flying. And then, the breakthrough: Ford's engineers finally perfected the moving assembly line for aircraft, something experts had said was impossible. The line powered up. Bombers crawled forward slowly at first, inch by inch, as teams swarmed around them like coordinated bees. Wings were attached at timed intervals. Turrets were lifted into place with overhead cranes. Engines were mounted with lightning efficiency. Wiring harnesses clicked into pre-measured channels. The impossible was becoming routine. Ford didn't just fix the system, he reinvented it. and the factory began to accelerate. The first complete bomber finally rolled out. Then another, slightly faster. Then another. Willow Run was gaining speed. The breakthroughs kept coming. When a shortage of skilled riveters threatened progress, Ford invented new power tools to reduce training time. When old designs slowed production, engineers re-engineered subassemblies for faster installation. Ford even redesigned the entire tail section so it could be built in a fraction of the time. Every day, problems turned into innovations. Every week, the line sped up. The factory that once struggled to produce a single fuselage now produced entire bomber sections that fit together with flawless precision. B-roll, massive fuselage sections moving across rails. Still, perfection was not enough. The Army Air Forces wanted output at a scale no one had seen before, a bomber every hour. It sounded insane. Even Ford's own executives doubted it. But Henry Ford believed in rhythm, in flow, in relentless refinement. So they pushed harder. They mapped every step, every tool, every second of the workers' movements. If someone took 4 steps to reach a tool, they moved the tool. If a part required 3 motions to install, they redesigned it to require 2. Efficiency became religion. Time became their enemy and their obsession. The factory hummed louder. Workers coordinated like gears in a giant human machine. Sparks flew from welding stations. Engines roared during tests. Every hour, Willow Run felt more alive, more dangerous, more powerful. And then it happened, the moment that history still remembers. The line reached full rhythm. The final station cleared one B-24. The next bomber rolled forward. Final checks finished. Engines spun. Mechanics saluted. And the factory clock ticked past 60 minutes. The impossible had become real. Willow Run produced 1 bomber every single hour. A complete 60,000-pound war machine, built by ordinary Americans who had never believed they could do something like this, until they did. Aviation experts who once mocked Ford fell silent. Journalists who wrote predictions of failure now wrote awe instead. The world had never seen anything like it. And Willow Run was only just beginning. Just when Willow Run seemed unstoppable, just when America began celebrating the miracle of a bomber every hour, the factory faced a twist so unexpected, so destructive, that it almost tore the entire miracle apart from the inside. Success had come at a brutal cost: endless hours, constant strain, and an exhausted workforce pushed to their physical and emotional limits. By mid-1943, turnover was exploding. Tens of thousands of workers quit every month. Willow Run needed 100,000 hires a year just to keep running. People slept in cars, in barns, on floors of half-built dormitories. The overcrowded living conditions near the factory created a crisis no engineer could solve. Workers collapsed from fatigue. Buses arrived late. The entire schedule, timed down to the second, fell apart again and again because the workforce was simply overwhelmed. B-roll, crowded worker housing, buses lined for miles, exhausted workers sleeping during breaks. And then came a much darker twist: sabotage rumors. Military intelligence agents began patrolling the factory after reports of damaged parts, loose bolts, and intentional slowdowns. Some believed enemy agents had infiltrated the workforce. Others thought labor tensions were boiling under the surface. In truth, many mistakes came from exhaustion, not malice, but suspicion poisoned morale. Supervisors cracked down. Security intensified. Workers felt watched, pressured, mistrusted. The industrial miracle began to feel like a prison. But this was only the beginning of the crisis. The biggest shock came from the sky itself: literal aircraft failures. B-24s built at Willow Run began showing dangerous structural problems during test flights. Some developed fuel leaks. Others suffered electrical failures. A few had wings that vibrated at high altitude, risking catastrophic collapse. Pilots grew hesitant. The Army Air Forces demanded immediate fixes. Aviation experts, who had mocked Ford from day one, seized their chance. They claimed mass production was to blame, that aircraft built on an assembly line lacked the craftsmanship needed for combat. Newspapers began whispering that Willow Run, despite its speed, might be turning out unreliable machines. It was a direct threat to everything Ford had built. B-roll, test flight footage, engineers inspecting damaged plane sections, tense factory meetings. Inside the factory, tension reached a breaking point when inspectors halted an entire section of the line after discovering a batch of faulty wiring harnesses installed across dozens of bombers. The line froze. Thousands of workers stood idle. Every hour lost was a bomber the front lines desperately needed. Panic rippled through management. The dream of perfect efficiency had collided with the reality of wartime pressure. This was the moment critics said Willow Run would collapse. But just as the crisis reached its peak, something extraordinary happened, something no one had predicted, something that remains one of the greatest industrial turnarounds in history. The workers saved Willow Run. Not Henry Ford. Not Washington. Not high-ranking engineers. The ordinary men and women who built the bombers every day were the ones who found the cracks, fixed the flaws, and redesigned their own workflow from the inside out. They formed quality circles, groups of line workers who met after shifts to dissect problems and rework solutions. Women who had once been dismissed as unskilled began leading troubleshooting teams. Electricians created new color-coded systems that prevented wiring mistakes. Riveters taught each other advanced techniques usually reserved for expert craftsmen. The same workers who were once blamed for errors became the heroes who eliminated them. B-roll. Women instructing new workers, technicians redesigning wiring maps, engineers listening to line workers. Meanwhile, outside of the factory floor, a far more dramatic twist was unfolding inside Ford Motor Company itself. Henry Ford, aging and increasingly ill, suffered a series of strokes. His son Edsel Ford, the one man holding the delicate balance between Ford Motor Company and military demands, was overwhelmed. The stress of managing Willow Run, constant battles with government officials, and the pressure of wartime leadership took a devastating toll. Edsel fell gravely sick. In 1943, at just 49 years old, he died. His death sent shockwaves through the company and the entire U.S. war industry. Newspapers mourned him as the quiet genius who had modernized American aviation. At Willow Run, thousands stood silent during a factory ceremony, knowing the man who believed in them was gone. Henry Ford returned to command, but he was no longer the visionary he once was. His memory faltered. His decisions became erratic. Tension inside management skyrocketed. Arguments erupted over quality control, engineering changes, and production speed. A leadership vacuum threatened to undo the miracle workers had fought so hard to save. B-roll, somber music, flag at half-mast, workers standing silently along the assembly line. And then, the most dramatic twist of all, the U.S. government stepped in. With Ford's leadership failing and Willow Run too important to lose, Washington pressured the company to accept new management. In 1944, the Ford bomber program was essentially handed over to the Army Air Forces and key partners from Consolidated Aircraft. The government quietly installed new oversight, new inspectors, new engineering teams. Willow Run now had two masters, Ford's industrial machine and the military's iron authority. Instead of chaos, this unusual dual control system created a strange, powerful synergy. The military brought discipline. Ford brought speed. The workers brought skill. And somehow, against every expectation, Willow Run didn't collapse, it got better. Quality soared. Defects plummeted. Output surged. The factory that had once struggled to produce one bomber at all now rolled them out with near-flawless precision. The twists, leadership crises, structural failures, extreme pressure did not destroy Willow Run. They forged it into something stronger, faster, and more efficient than anyone believed possible. B-roll, proud workers sending off completed bombers, test pilots giving thumbs up, hundreds of planes lined for delivery. The world had expected Ford to fail. Instead, the twists had set the stage for the factory's most legendary moment, the staggering finale that no expert, no critic, and no engineer had ever imagined. The moment Willow Run became the greatest bomber factory in human history. Narrator, slow, heavy, dramatic. As the dust settled over the ruined fields of Europe, one truth rose from the smoke like a warning written in the sky. German artillery, once the sharpest blade of the Wehrmacht, had finally met a force it could not outthink, outgun, or outrun. Fire, the turning point no one saw coming. For years, German commanders believed their artillery doctrine was untouchable. It was disciplined, precise, and deeply integrated into their battlefield strategy. Their forward observers were legendary, their guns reliable, their calculations flawless. Entire offensives were built around the confidence that once the German batteries opened fire, the enemy would either retreat or be buried where they stood. But by 1944, something changed. The battlefield began to tilt. Not because Germany became weaker, but because the Allies had become unpredictably smarter. What once took minutes for American counter-battery teams to respond now took seconds. German guns that had survived on speed and concealment suddenly found themselves exposed. And on one morning, a morning whispered about in war diaries, the collapse became undeniable. Direct-hit fire mission, counter-battery. It began with a single German artillery regiment positioned along a tree line near the Ardennes. To them, it was a routine bombardment, soften enemy positions, halt a possible breakthrough, and pull back before Allied reconnaissance could pinpoint their location. But this time, the Americans were already listening. With newly integrated radar, sound-ranging equipment, aerial mapping, and fused intelligence from multiple divisions, U.S. forces had the German guns triangulated before the first shell even hit the ground. Within 24 seconds, American counter-battery units answered back. Not minutes. Seconds. The German gunners barely touched their ammunition crates. They didn't even realize the battlefield had changed. The first American shells landed with surgical precision. A battery commander later wrote, "We fired one volley, and then hell answered. We had no chance to move. They knew exactly where we were before we did." Collision, the death of the invisible gun. For the first time in the war, German artillery crews faced an enemy that could see without scouts, calculate without hesitation, and strike without warning. Before 1944, a German battery could fire for 2 to 3 minutes before relocating. After mid-1944, they barely had 20 seconds. The Americans weren't shooting blindly. They weren't reacting, they were predicting. They could map sound waves. They could read muzzle flashes from miles away. They could detect disturbances in the air itself. The German ghost guns, once nearly impossible to target, became beacons. And on that day, almost the entire regiment was destroyed within 7 minutes. Satellite antenna intelligence won the battle before artillery fired. Modern historians now agree. American counter-battery strength wasn't just firepower, it was information warfare long before the term existed. Every gun position, every supply route, every fallback trench, every camouflage net. The Americans were assembling the battlefield piece by piece, turning the fog of war into a high-resolution map. When a German shell landed, U.S. systems didn't hear one sound. They heard a story, the angle of fire, the distance of the gun, the type of cannon, the position of the battery, the elevation of the barrel, even the likely escape route. This wasn't just artillery. It was mathematics versus instinct, data versus doctrine, precision versus tradition. And tradition lost. Crossed swords, we weren't fighting men. We were fighting equations. Survivors from German artillery regiments wrote haunting entries in their diaries. One noted, "Our guns still fired true. Our crews were experienced. But now, the battlefield belonged to the Americans the moment we touched the trigger." It wasn't bravery. It wasn't even technology alone. It was a complete shift in how war was understood. German units that had once been mobile, disciplined, and confident now found themselves trapped in kill zones they didn't even know existed. Entire divisions were forced to change tactics, not because the enemy was more powerful, but because the enemy had become impossibly precise. The ground itself betrayed them. Where German spotters once trusted terrain, foliage, mist, and timing, America trusted nothing except measured data. Every shell produced a fingerprint in the air. Every vibration left a clue. Every flash left a trail. The Allies learned to read the battlefield like a book. A crack in the distance? 155 millimeters. A low boom from the forest? 105 millimeters, high elevation. A second echo 3 seconds later? Multiple guns, single line. Slight shift in reverberation? The battery is relocating aim here. German artillery wasn't being outgunned. It was being decoded. Fire the final minutes of the regiment. As the American barrage intensified, German crews scrambled to limber their guns to move, hide, survive. But the counter-battery fire adjusted faster than they could breathe. One crew tried to retreat using a narrow road, only for American shells to fall precisely across their escape route, a perfect block. Another team tried to scatter into the forest, but tree bursts turned the woods into a storm of steel and splinters. By the 7th minute, the regiment, one of the most decorated in that sector, had ceased to exist. Not because they were inexperienced. Not because they lacked courage. Not because their weapons were inferior, but because for the first time in modern warfare, knowledge moved faster than fire. Checker flag the battlefield aftermath. When U.S. infantry advanced hours later, they found shattered gun carriages, overturned limbers, and silent barrels still warm from the opening volley. Not a single gun had survived long enough to be pulled back. It was the end of an era, the moment German artillery's reputation met its immovable truth. Speed is no match for prediction. Strength is no match for precision. And experience is no match for intelligence. Microphone narrator, slow, final, echoing. It was not brute force that defeated German artillery that day. It was not overwhelming numbers or superior guns. It was a new kind of warfare, one that saw the enemy before they fired, one that understood their rhythms, their habits, and their very heartbeat. A war won not by the biggest guns, but by the smartest minds.